Hello friends, welcome to the Formula Engineering classroom. And as we discussed in the previous lecture, that how we can measure the positive gauge pressure by using the YouTube manometer. In this lecture, we will discuss one problem, and after that, we will understand how we can measure the negative gauge pressure at particular gauge point. Okay, so this is a engineering services exam problem, and in this problem, this is the given figure, and in this case, the problem is that we want to calculate what is the head of water at the point A. Means we want to calculate what is head of water at point A. Okay, now that I'm saying this is H of water at point A. We want to calculate this one. So in this problem you can see here, that is, there is water, this is the pipe, this is the cross section of a pipe, and in this pipe water is flowing, and water is up to this depth, that is 56 centimeter, and specific gravity of water is given, that is 1. And now there is manometric fluid, that is mercury, specific gravity is also given, that is 13.6, and the level difference in the mercury is 45 centimeter, and above this mercury there is benzene, whose specific gravity is also given, that is 0.88, and height of benzene is also given, that is 50 centimeter, and above this one there is atmospheric pressure is exerted, this is PATM. Okay, now so we want to calculate the head at the point A. So first of all, what is the sense of head of water? So first we will try to calculate what is the positive gauge pressure of water at the point A. Then we will convert that positive gauge pressure into the height of water. That is actually the head of water. Okay. So to solve this type of problem, first of all, we are considering a level here, and we are marking this is 1 and this is 2. Now obviously, according as we discuss Pascal's law and hydrostatic law, so according to hydrostatic law, we can say that is at the point 1 and 2 at the same depth here. Okay, according to Pascal's law, we can say that is pressure at the point 1 and the pressure at the point 2 will be same. That's why there is a balancing here. Okay, this is an equilibrium state. So we can write that is pressure at the point 1 P1 will be equals to pressure at the point 2 P2. Okay, so first we'll try to calculate what is P1 is. So I'm writing that P1 is equals to, so first of all, this is the gauge pressure at the point A, and definitely this is unknown, so I'm writing this is PA. Okay, then this gauge pressure remains same at the same level here. Now as we are going down here, so obviously when we are moving in depth, the pressure intensity increases, and this is water, so we'll write plus, this is rho of water, into G into H of water. Okay, up to this point, this is rho G H according to hydrostatic law. So now we are here, so at the point 1 this is the pressure intensity, that is PA plus rho of W into G into H of W. Okay, now we will calculate the pressure at the point 2, so the P2, so P2, so we'll start from here, but here you can see this is the atmospheric pressure, and we are only considering the gauge values because at the point A the pressure is gauge pressure. So for us, the atmospheric pressure we are considering as a reference point. So at this free surface of benzene, the gauge pressure is 0. Okay, then we are moving down in the benzene, so pressure increases here. So in this case we will write that is rho of benzene into G into height of benzene. Okay, so now we are here, Now again we are moving down here, so again the pressure increases, but here the fluid is mercury. So according to hydrostatic law, we can also write rho gh for the mercury, and we will be here. So pressure increases, so I am using plus here. So this is rho of mercury into G into H of mercury. Okay, so this is the pressure at the point 2 here. And now we know that is P1 equals to P2. So let's equate them. So we can write that is PA plus rho W G HW equals to PB into G into HB plus this is rho actually. This is not P, this is rho. Contrast writings. This is rho. This is rho here. Okay, so this is rho here. So rho of mercury into G into H of mercury. Okay, so we want to calculate this one. So this is unknown. So this is unknown PA. Now, so specific gravity of water is given, that is 1. So obviously we can write that is rho of water will be 1000, and this will be G here. We know the value, so we can write this is 1000 into 9.81, and this is 56 centimeter. So we can write this is 0.56 meter. 0.56. Okay. Then rho of benzene. So as specific gravity of benzene is given, so we can write rho of benzene will be 0.88, that is specific gravity, into density of standard fluid, that is water. So this is the density of benzene into 9.81 into height of benzene is 50 centimeters. So we can write this is 0.5 meter. Okay, plus so rho of mercury. So again specific gravity of mercury is given 13.6. So we can write this is 13.6 into density of standard fluid, that is water, 1000 into 9.81 into 0.45. Okay, so all values are known. So from here we can calculate what is pressure at the point A is. Okay, so let me calculate this one. So this value is equals to, this is 58860 Pascal. Okay, actually I'm writing the value of PA. Actually I'm subtracting this value from all these values, and finally I'm writing this is 58860 Pascal. This is PA. So this is the gauge pressure at the point A. Obviously this is gauge pressure. This is gauge pressure. Now, but the question is, what is the head of water at the point A? And we get the value in terms of Pascal, but he required the value in terms of meter of water. Okay, so we require this value in terms of meter of water. So I think by the use of hydrostatic law, we can convert this gauge pressure in terms of meter of water. Means we can say that there is how much height of water required to create this much of pressure. So to calculate this one, we can write this pressure, that is PA gauge, is equals to rho of water into G, and actually we want to calculate the head of water at the point A. So this is head of water at the point A. So we know this value. This value is, let I'm solving this here. This value is 58860 equals to, so this is 1000, rho of water 1000, this is 9.81. So I'm writing here this is 9810 into H of water at the point 8. This is head of water. So by solving this one, we can write there is head of water at the point A is equals to 6 meter. and this is our answer. Okay, this is our required answer. So this is the head of water at the point A. So what is the sense of this one? So actually you can say at this point A, the pressure intensity is 58860, that is the gauge pressure intensity, and this is due to the water. And let's suppose this pipe is connected to a tank. Sorry, this pipe is connected to some tank that I'm drawing here. This pipe is connected over here, and this is the center line of the pipe. This is the center line. So in this tank, the level of water from this center line is 6 meter. This is 6 meter. Okay, so we are saying this is head of water is at the point A is what? This is 6 meter. It is not necessary that there is a tank here. Due to some other reasons, the pressure at this point may be 6 meter of water. Means in the sense we can say that there is the head of waters. It simply means that is the height of that fluid that is required to create the gauge pressure at that particular point. That we are defining the head of water. So for this problem, at the point A, the gauge pressure is due to water is 58860, and due to create this pressure, the required height of water above the center line of pipe, it is 6 meter. Clear? Okay. Okay, now we will understand the concept of measurement of negative gauge pressure. That is, I'm writing negative gauge pressure, or we can also define this is vacuum pressure. Vacuum pressure. Okay, so let's suppose initially this is our YouTube manometer, and there is some manometric fluid filled in this one, and here is the level of that manometric fluid both sides. So let this is our manometric fluid, and both the limb are open to atmosphere. So the level of the manometric fluid, both the limbs is same. Let specific weight of this one is Wm. Okay, now let I am connecting this left hand side limb to some pipe or container. Okay, so this is the cross section of a pipe, and this is the center line or center of the pipe, and in this pipe some fluid is flowing, and the pressure of this flowing fluid at the point or at the center point, if I'm saying this is A point, is less than the atmospheric pressure. So if this is the less than the atmospheric pressure, and here the pressure is atmospheric, so obviously this pressure is higher, and at this point the pressure is less than atmospheric pressure, that is negative gauge or vacuum. In that case, the level of manometric fluid is going down in this right limb and going up in this left limb. So let's suppose in this left limb this is rising over here. Okay, and in this side, right hand side, this level is goes down, means in this case there is no fluid here. So that just a minute, I'm saying there is no fluid here. This is going down this side here, and again we know that the specific weight of this flowing fluid is that I'm saying W1. Okay, now at this point A, the pressure is unknown, that is obviously negative gauge pressure. And let's suppose this is the line here, and the height of this flowing fluid, that I'm saying this is H1. Now, the difference in the manometric fluid level. So obviously in the left hand side limb, the level of the manometric fluid is here. In the right hand side, the level is here. So difference in the level of manometric fluid is, I'm saying this is HM here. Okay. So in this case, we want to calculate what is the pressure at this point A. Obviously, this is gauge pressure and this is negative gauge pressure, that is vacuum pressure. So that I'm considering a level here. So initially the level, when the manometer is not connected to some device, the level was here. And after the connection, level is here. Let I'm saying this is 1 dash and 2 dash. Now again, from the from the hydrostatic law, we can say that there is P1 dash will be equals to P2 dash. Okay. Obviously at this level, the pressure intensity will be same here. Okay, so first we will try to calculate what is P1 dash is. So first of all, to calculate the P1 dash of pressure intensity at this point, we know the pressure intensity at the point that is unknown. Let I'm saying this is PA. Okay, then this PA is same throughout this line or this level. Now we are moving down in this fluid, so the pressure intensity keeps increasing. So we can write plus here to increment of pressure intensity W1 H1. Now we are here. Now again we are moving down in this manometric fluid, so again the pressure keeps increasing. So we can write this is Wm, that is specific weight of manometric fluid, into Hm. Okay, so now we are here. So this is the gauge pressure intensity, that is P1 dash is the gauge pressure intensity at the 1 dash. So what is P2 dash? So as P1 dash we are saying this is gauge, this will P2 dash will also be gauge. But this is the free surface of manometric fluid, and over here the atmospheric pressure. So means at this free surface the gauge pressure will be 0. So we are writing this is 0. Now that equating 1 and 2, we can write that is PA plus W1H1 plus WMHM is equals to 0. So we can write PA is equals to minus W1H1 minus WMHM. Okay, so we can see here this PA is the gauge, but this is negative. So this is the negative gauge pressure or vacuum pressure at the point A in this pipe. Now if we want to calculate the negative pressure or negative pressure head at the point A, means we want to calculate not in terms of Pascal, we want to calculate in terms of height of this fluid flowing in this pipe or container. So obviously we can convert this pressure in terms of head or height. So let if I want to convert this pressure in terms of this flowing fluid, let's suppose some water in terms of water height. So we can simply say that is PA divided by rho of water into G. Obviously when I will divide this pressure intensity PA by this rho W into G, the unit of this PA by rho G will be in terms of H. So that I'm saying this is HW. So this will be equals to, so minus W1 upon W of water, that is rho G we are defining here, H1 minus Wm upon W of water into Hm. Okay, so now we can say this is HW will be equals to, so I think the specific weight of some unknown fluid divided by specific weight of some standard fluid, that is water here, this will be the specific gravity of this fluid in this pipe or container. So we can write this is minus specific gravity of this unknown fluid into H1 minus, and I think this will be the specific gravity of this manometric fluid. So we can write this is specific gravity of manometric fluid into HM. So this is how we can convert the Pascal term in terms of meter or the pressure in terms of head. Okay, so I think the point is clear. How can we calculate the negative gauge pressure? So in piezometer we can't calculate the negative gauge pressure values, but by the use of U2 manometer we can easily calculate the negative gauge or vacuum pressure. Thanks for watching. See you in the next lecture. Till then, take care of yourself. And guys, please subscribe the channel, like, comments the doubt, and share the knowledge as much as you can. Thanks again.